All right. So, okay, so this is the last rule in terms of how to do a derivative. So we've done power rule, right? We started with the power rule, and then we did the product rule, and then the quotient rule. Okay, those are the big rules. Those are the ones we use a lot. Chain rule is the one we're going to use quite often too. Okay, chain rule is one that is used a lot for functions that are functions inside of functions, composite functions. Okay, but before we start that, I want to give you, here's a multiple choice question that I found off of an old test. It was found off of an old test that I wanted to throw at you. Get about 2 minutes. Actually, this question, if you can't do this question within about 30 seconds, you probably won't be able to do it because it's either you know it or you don't, but try it. Just try it. I'll give you about a minute or two, and then we'll talk about it. Okay? This is like I said, when we do eventually take a test in a few weeks, this is one of the questions that I have, and I just pulled it so we could go over it. So we've already seen it. You already had a quiz on it, actually. Okay? Take a look at it. Take about 2 minutes, see what you can come up with, and then we'll talk about it. Okay, so what in the heck does that mean? Because that's basically if you don't understand what that is, you have no idea what you're doing. But if you do kind of recognize that, you can kind of formulate what your next plan is, what your next step is going to be. So it's either you recognize that and you're like, oh, I know what they're asking, or you're like, I have never seen that. If you have never seen that, I must be the worst teacher in the world, because we have done that. You've actually had a quiz on that. Okay. So can anyone tell me what that is, or where that's from, or what in the world it's asking? Yes, go. Right. And what did we do? We just found the derivative, right? We found the derivative, right? Let's see. Let me see if I have it in my notes. First thing we did with the derivative, right? First thing we did when we were finding the derivative, but we were doing it the long way, right? Here it is right here. Okay. That's what it is. Yeah, that's exactly what it is. All we're doing is finding the derivative. That's all we're doing. So it's a derivative question. Okay. That's the first step. Good. If you recognize that, you're good. You can kind of figure out what your next step is going to be. Now, do you have to use this form? Do you have to do what we did back then to do it? No, you know different methods now, right? Okay. So what is this question really asking me? What is it really asking? Does anyone know what it's just really asking? It's asking me, yeah, remember this part right here? That part right there is the original function. That's the original function. This part, I don't care about. This part, I don't care about. This part, after I know it's a derivative question, I don't care about the rest of it. I only care about the original function. So what was the original function? Tangent of x. So what they're doing is they're saying, okay, find the derivative, find f prime, move this, for that guy when x equals pi over 4. That's what they're asking you to do. You've done that before. You've seen it like this, right? You've seen it like this, but you've also seen it like this, okay? Guarantee you next test we take, there will be at least one question that looks like that. Guarantee you. It'll be a multiple choice question, just like it was here. It's, do you recognize that it's asking you to find a derivative? That's the question, okay? So the first thing we got to do is find the derivative of tangent. What's the derivative of tangent? Does anyone know? It's on your sheet. It's on your notes. The derivative of tangent. Secant squared. Good. Secant squared of x. Right? Part 1 done. Part 2. Now I got to plug in pi over 4. And I'm going to move the secant, the squared part, I'm going to move that to the outside because that's really what it means. So now I'm going to go to my unit circle and I'm going to figure out what secant of pi over 4 is. Okay. So secant of pi over 4 is root 2. Root 2. So this is root 2 squared. Okay. And what is root 2 squared? Just regular old 2, right? Done. Letter A. Okay. When we did this, the first day we did this of derivatives, I told you, I'm like, you're going to have a question like this on your test eventually when we take it. You're going to have a question like this and it'll be a multiple choice. So that's why I dug and found this one, because I wanted to show you an example of it. Okay. Most of the time, when they give you these types of questions on multiple choice, it's going to be a trig, something trig, sine, cosine, tangent. One of those three. Usually they don't use secant. Usually they won't put secant up here or cosecant or cotangent, but most likely it'll be sine, cosine, tangent of something. Your focus just goes directly to the green. Everything else you block out. Once you say, oh, it's just a derivative question. Okay, so the first thing you do is find the derivative of this guy, whatever it is, and then you plug in whatever they tell you to plug in, and then you're done. Okay, it's seen if you recognize that this is a way of finding a derivative. You don't have to do anything with anything else, with any of this other stuff, the limit or anything. You don't have to. Once you know how to find derivatives, you use your other rules that we've done. Okay. All righty. Okay, so it's not on yours, but like I said, it will, when I post it, you'll be able to see it. Okay, and then it'll be on the video too. Okay, so that has nothing to do with what we're doing today, but I wanted to I saw that problem yesterday and I wanted to put it on here because I had told you about it a few weeks ago, and I wanted just to remind you about what it looks like, okay? Okay, so now back to chain rule. Chain rule is our weapon for deriving what we call composite functions. Composite functions, or functions other than just plain x. Composite functions are functions that have been combined, okay? Or a function inside of another function, okay? Here are some examples of the types of functions. Do I put this? Oh, why did I do that? Oh, well. Okay, so I'll show you a list in a second. So you see, this is the rule here. If you have a function inside of a function, you take the derivative of the outside function, the one you started with, and then you take the derivative of the inside function. And you join them by multiplication, okay? Sometimes, not today, but eventually when we get into this, there will be many layers to it. So you'll have the inside of this function and then the inside of this function. That's why it's called the chain rule, because they chain together, okay? They chain together. The toughest part is when I need to use the chain rule, okay? So let me pull up. I was gonna put this in the notes, but I forgot. Let me see, where are my notes? Let's see. In here, here we go. I was going to put this table, but for some reason I forgot to put this table on your notes. So these are examples of when we use the chain rule, and these are examples of when we don't use the chain rule, okay? Because some of them look very, very similar to each other. Some of them look very, very similar, okay? So the left, we do not need to use the chain rule. We can do them right now, okay? Thank you, okay? On the left, we don't need those. We don't need the chain rule. We can use other rules, right? We can use the other rules. This one, we would use the difference rule. This one is just sine of x. We would do it like we did the trig notes. This one is just sum rule, or the difference rule, the same thing here, right? What's the difference here though? What's the difference over here? We do need to use the chain rule for this. Why? What's different about it? Top one has a square root, right? Top one has a square root. What about this one, the sine? What's different about sine? Yeah, the angle's being multiplied by 5, right? So it's not just the angle by itself, it's 5 times the angle, right? This guy is not really the same. This guy's kind of like the first one, but you see that it's got a 7th power, right? This one here, subtle little difference, right? Okay, so these we're going to need to use the chain rule. These right here, the left side, we don't. You could do them right now. Okay, we could do each of these right now. So the difference is, so the key today is when do we need to use the chain rule and when can I use one of my old rules? Okay. Well, here's the thing. We have, if we have an inside and an outside and an inside function, we need to use the chain rule. So look at the first one here. Square root x squared minus 1. We know we need to use the chain rule because it says it. What's the outside function? Or sorry, let's start with the inside. What's the inside function here? What's the inside? Does anyone take a guess? What's the inside function going to be for root x squared minus 1? Yeah, that's the inside function. What would be the outside function? The square root of x squared minus 1, right? The square root of x squared minus 1 is the outside function. The one on the inside is x squared minus 1. Okay, let's look at this guy here, sine of 5x. What's the inside function? Sometimes it's easier to look at the inside function. What's the inside function of that? What's embedded inside of that thing? 5x. 5x is the inside function. What's the outside function? Sine of 5x, yeah. Here's the thing, the outside function is always going to be the whole thing. The outside function is always going to be the entire thing, okay? So here we go. We got another x squared minus 1. This one's to the 7th power then. So what's the inside function there? What's the inside function for x squared minus 1 quantity to the 7th power? What's the inside function? Get room? There you go. Outside is always the whole thing. So this entire thing would be the outside function. Okay. Once you kind of get that idea, chain rule is really kind of easy because it's a bigger power rule. And the power rule is probably the easiest rule we have for derivatives. So really it's just a bigger power rule. So once you kind of see which one's the outside and which one's the inside, it's like the power rule, okay? So this guy here, this last one here, first of all, x, we don't need to use the power rule for x, that's just x. But this guy here, again, just kind of like sine of 5x, x squared is the inside, tangent of x squared is the outside, okay? So the outside's always going to be the whole thing. The inside's going to be the inside, okay? All right, so let me go back to, so what I want you to do here on this page here, the next one, tell me what the inside and tell me what the outside's going to be. I don't want you to do anything other than tell me what the inside and what the outside's going to be. These are where you're going to have to use chain rule. So tell me what the inside and tell me what the outside is. Hey, come on. We're just getting started, so you haven't really missed it. Okay, so letter A. What's the inside function here? What's the inside function for letter A? 5x squared, good. Outside function is always the easiest. It's the whole thing. Outside is cosine of 5x squared. Yeah, so outside function for all of these is just going to be the whole thing. Square root 3x plus 1. Sine squared of x, 1 over 5x minus 1, okay? The inside function is the one that you guys kind of have to find, okay? So this guy B, so if we know the outside function is square root x squared plus 1, what's the inside function? Okay. This guy here. Remember, this is the same thing as sine of x. So whatever I get for sine of x, I square it. Which one, what would be the inside function? This one's kind of got multiple layers. What would be the most inside? Even inside of that, that's an inside. I would say sine of x is definitely inside, but there's actually something on the inside of that. Not x squared, take away the squared, just the x, yeah, just the x. I would say the x is the most inside. And then the inside of, it's kind of like, have you ever seen those Russian dolls where you have dolls inside of dolls inside of dolls? So you start with this big doll and then you take it apart and then there's another doll inside and then another doll. And then by the time you have all the dolls, you have like a long old line of dolls. They all look the same, but just different sizes. It's kind of the same way of like that. One of my teachers in college told me to think of it like a peanut M&M. The whole M&M, right? The whole thing that you see in the package is the outside. And then on the inside, you have chocolate, right? And on the inside of that, you have the peanut, right? It's the same type of thing. So this one, it has 3 layers to it. X is the first layer. That's the inside layer. That's the peanut, okay? The inside of that is sine of x. That's the chocolate. And then the outside is the entire thing. Okay, so the outside is the entire thing, sine of x squared. The inside, so this has got 2 layers of the inside. So when I say inside, so the first inside is sine of x, and then the next one is x. That one's got 3 layers in it. Most inside, middle inside. Okay. This one's only got 2 layers. Let's start with the inside. What is the inside here? Because we know the outside. The outside's 1 over 5x plus 1. What's the inside there? Yes, it is 5x plus 1. Okay. That right there is the hardest part of what we're doing. Because once you understand to do that, once you understand the outside and the inside, finding derivative is just using the rules we've already used. Power rule, quotient rule, product rule, sum and difference rule. Okay, so that's the hardest part. So now let's look at the first one. But this time we're actually going to find the derivative of this one. Okay, so the chain rule says, we know we have to use the chain rule here because there's an outside and there's an inside. So the chain rule says, take the derivative of the outside and multiply it times the derivative of the inside. That's what the chain rule says. Well, we know the outside and inside, don't we already? What was the outside? So what was the outside, what we said the slide above, or the slide right next to it? We said the outside was what? The whole thing, right? The whole thing. So we got to find the derivative of the whole thing. The whole thing. This is the inside part, right? So I don't care about the inside part right now. The inside part will have its day. It's going to come next. The inside part, I'm not worried about right now. I'm worried about everything else. So if this is the inside part, I'm worried about everything other than that, which is this, right? Just cosine. Well, what's the derivative of cosine? Negative sine. So the derivative of the outside is negative sine inside rewritten. I didn't find the derivative of the inside because it's going to have its day. It's coming right afterwards. I can see that right next. The next thing I'm going to do is find the derivative of the inside. What's the derivative of the inside now? 10x. Change that around. So you put the negative 10x in the front times sine of 5x squared. Done. Okay, you can put a multiplication there if you want. Yeah, Rob. No, so when I'm looking at the inside, so like I said, when I'm looking, so there's two parts to it, right? So we have a whole thing, right? We have the outside here, that's the whole thing. And then we have the inside, right? Okay. So when I'm looking at the whole thing, the outside, I'm only looking at what's just yellow. That's just the cosine, right? Everything else stays the same. When I'm looking on the inside, I'm looking at what's just green. That's just 5x squared. That's why I don't care about, yeah. So that's why I didn't care about 5x squared on the outside because I'm like, I'm going to handle that later. I'll take care of that later. I'm going to find the derivative later. So that's why I didn't do that. Okay. All right, let's look at the next one. So we already said this one. We already did this one earlier in terms of outside and inside. We said the inside is this guy here. The outside is the whole thing. Okay. When we're finding derivatives, what's like the key rule? What's like the, not, I don't want to say rule because it's not one of the rules. What's the golden kind of rule? I hate using the word rule because it's not one of our rules, but what's the golden rule when taking a derivative of anything? I think it's written somewhere here. It's written right at the top of this page. I need a powers. I don't want roots, right? I don't want roots. Roots I don't like. Fractions I don't like. I want powers. Powers are what I need to find derivatives, okay? So the first thing we got to do is rewrite this guy. Rewrite it with powers. It's not going to change it. I'm not changing anything. I'm just rewriting it so that I can find the derivative. So it's 3x plus 1 to the 1/2 power. Okay. This is still the inside. And this is still the outside. So the first thing I have to do with the chain rule is find the derivative of the outside. The yellow part, the yellow, only the yellow. So the yellow part, I'm just looking at the yellow, don't look at the green. I know it's kind of hard because they're stuck together. They're like one's inside of the other, but just look at the yellow part. Isn't the yellow part just something to a power? Isn't all that, that's what it is, right? What do we use when we have something to a power? Power rule. That's power rule, right? That's all it is, just power rule. That's what I'm going to do here. Okay. So I don't care what that something is. That something will be dealt with later. So what did we do with power rule? Power rule, what am I going to do with that 1/2? Move it to the front. Good. And then what did I do after that? Subtract 1 from it. So I'm going to get negative 1/2, right? Subtract 2 over 2. Right? That's the outside. Now the inside. Now don't look at the yellow, look at the green. What's the derivative of the green? Just 3. Done. Now, you won't see that answer A, B, C, D. You won't see that answer there because we have to clean it up, right? We have negative exponents, can't have negative exponents. We got a 3 times a 1/2, so we can multiply those together. Okay, so the rest is not, we're done with the calculus. The rest is just cleaning it up. So negative 1/2 power means 3x plus 1 is going to go down here. And it's a root because it's 1/2. Done. Okay. So anytime you need to doing a derivative of something and it doesn't have a power, it needs to have a power. Okay. We need powers in order to find derivatives. All right, let's look at this guy right here. This guy's got a power, squared. But I need to rewrite it so that it makes a little more sense to me. Okay, so I'm going to rewrite it to look like this. Same thing, says the same thing again. It says the same thing, but it makes a little more sense to me in terms of what's the outside and what's the inside. So the outside, wait, let's do the inside first. The inside is sine of x, right? But then what's the inside of that? X, right? And then the outside is everything that's not highlighted. The whole thing, right? Okay. So I got 3 layers of this guy. 3 layers. So I'm going to do the outside first. Well, the yellow, isn't that just something to a power? Again, that was like the other one. It's something squared. Well, if it's something squared, I'm going to use the power rule. 2, everything else stays the same. Minus 1, I get just to the first power. Go to the inside. The inside now is the green. What's the derivative of sine? Cosine. Everything else stays the same. Now the last inside. What's the last inside? x. What's the square root of x? Or sorry, what's the derivative of x? 1. Clean it up. 2 times 1 is 2. Since it's first power, I don't need that the parentheses anymore. There you go. Okay. This guy right here. Mm-hmm. Yep. For the last one? Yep.
What did you multiply cosine by 2?
It is kind of multiplied by 2. It's got the 2 in front. So because it's all multiplication here, because it's 2 times this, I don't have to distribute. If this was a plus and this was like this, then yeah, I'd have to multiply it times 2. But because it's all multiplication, I don't have to give it its own 2. Okay. Yes. Let's see. Oh, so there's 1/2 here? Yeah, the reason why you're talking about distributing like this, the reason I didn't distribute it like this is because of this power. I can only distribute this when this is a positive 1. If this is a positive 1, go for it. Absolutely go for it. But anything other than a positive 1, you can't distribute it. Yeah. Okay. All right. So this guy right here. What do I do first? What's my first step going to be? Yeah. There you go. Good. I like that. Doesn't have an exponent. It's got a fraction right now, right? So here's the thing. A lot of you would look at this question and say, oh, use the quotient rule. That's okay. Quotient rule will work. Okay, quotient rule will work. If you did quotient rule on this problem and you did it correctly on the test, you will get the right answer. Okay, so I don't want to make it seem like chain rule is the only way. I'm just showing you a different way. Okay, so if you wanted to go, you know, low times the derivative of the high minus high times the derivative of the low over the low squared, you would get the same answer we're going to get. Okay, you would absolutely get the same answer. I'm just showing you a different way. Because I know some of you look at that and be like, why can't we use quotient rule? You can, okay? And like I said, on a test, I don't tell you which rule to use. I'm not like you have to use chain rule. You have to use quotient rule. That's up to you to which one you're gonna use, okay? So like I said, on a test, if you see that problem and you think quotient rule is the best option, go for it. You will get the right answer. If you do everything else correctly, you will, okay? But for today, since we're learning about chain, we're gonna do chain, okay? So good. So let's change it to a power. What power will that be? There you go. Yep. The whole thing to -1 power. So now we have an inside. Everything else is the outside. Okay. That right there is probably the hardest part. Once you can get there, the rest I find students can do really well. Doing the actual rule, doing this part here, where you're actually doing the derivative, students can do really well because we've been doing it. But when I see mistakes, it's that you don't do that, right? It's always the hardest part, rewriting it and finding out what's the inside and what's the outside. Mm-hmm. Yeah, Ella? Mm-hmm. Yes. Yes, you are allowed to have a negative exponent, absolutely, until the very end. Until when you're saying, this is my answer. If you're saying, the only time, that's a great question. When can you not have a negative exponent? When you're saying, this is my answer here, or you're entering your answer in, then that's the only time it can't have a negative exponent. Every other time, it's okay. All right. Yeah, it's a great question because I see that a lot of times. I see on your quizzes, I saw you guys have some negative exponents. It's okay to have negative exponents until the very end when you're saying, this is my answer boxed, or this is my answer typed in, okay? So the yellow is just something to a power, right? It's just something to a power. That's all the yellow is, right? So let's do that. Everything else stays the same. So something, so I'm going to move the -1 to the front because that's what the power rule says. Subtract 1 from it, and I'm going to write everything else the same. Because I'm not worried about the green yet. The green will be handled in the next chain. Okay. Times, now I got the green stuff. Now I got the green. So what is the derivative of the green? It's regular old 5. Okay. So I see that I have, so I can't distribute the -1, right? Can't distribute the -1 because this isn't a positive. If this was a +1 power, distribute your heart out. But because that is, I can't distribute. But what I can do, this is a multiplication problem. This is this times this, right? Times this. So I can do some multiplication, right? I can multiply this guy and this guy here. And then this stuff here stays the same. Now, again, I'm not going to present that as my final answer because it has a negative exponent. So now I got to change it back. So now I have to change it back. Everything with a negative exponent, I have to fix so that it doesn't have a negative exponent anymore. So where does the -5 go? On top or on bottom? It stays on top because that one doesn't have an exponent of -2. That one's just plain -5. The bottom here, though, is squared. So since, let's go back real quick. Let's just real quick. So remember I said you could use the quotient rule for this guy too? What would the bottom be of the quotient rule? If you use the quotient rule for this guy, what would the bottom have been? Close, 5x plus 1 squared. Yeah, 5x plus 1 squared, right? And what did we get as our answer? The same thing, right? So you would have gotten the same answer had you used the quotient rule. Now, we didn't do the top. We didn't do anything with the top. But if you had done the rule the same way we always did, you would have gotten the same answer. Okay? So what we're going to do on Thursday and Friday is just investigate this more. Get better at it, right? Because right now, to some, it probably seems a little, I'm still not putting the pieces together. That's what we're going to do tomorrow. Okay? I'm not going to give you an assignment today because, again, you're just still kind of putting the pieces together. We'll do some practice. Don't worry. We'll do some extra practice, but I'm just trying to kind of lay the foundation for the rest of the chain rule. Okay? All right. So we'll pick it up where we left off tomorrow. Nothing assigned that's new. I'm not going to assign anything new today.